Hi everyone, I'm Vinay Gumorbanda, a computer science master student at Cardiff Metropolitan University. So in this presentation, I will introduce a comprehensive repair management system developed as a part of my advanced programming module. So this system supports LMP technologies in handling customer repairs, technician workflows, and administrators. We will explore the software architectures and use of OOPS principle and design patterns and exception handling techniques. And let's dive into how each piece of system contributes to solving a real world problem in a modular, extensible, and maintainable way. So let's get into the case diagram. Like you can see, the case diagram has three actors. They are customers, technicians, and admins, and each of them play three different roles. Then the system is structured around these three actors. They are customers, central administrators, and technicians. Like we first go on to customers. Customers can register and upgrade their account, book repair appointments, and view promotional offers and updates. Like we can see, they can log in and they can book repair, they can view notifications, they can see the promotional offers. The next slide, we can discuss about the role of admin. Admin plays a central role. They register walk-in customers, assign job to the technicians, manage spare parts inventory, and send out promotional materials for the customers, and flag audio accounts, and the use of case diagram slide illustrates the relationship clearly. We can see admins capture the customers and they assign jobs to the technicians and they assess jobs and they can generate bills, they can send promotions to the customers, and they log in includes update profile and update equipment, and they plays a crucial role between the technicians and customers. The next slide we're going to discuss about the role of the technician. Technician has a very limited access when compared to the admins. Like they are limited to their assigned jobs, they can view details and update statuses. Like they can only log in and view allocated jobs and record repairs. That's it. Like they have a very limited access when compared to the admins. And this is how the use of diagram on the slide illustrate the relationship of clearly. And the stage was very important in shaping the user flows and planning the class responsibility in the next phase. In the next slide, we're going to discuss about the class diagram. Once the cases were defined, I move on to the design the class structure. At the center is an abstract class called user, which holds shared attributes like name, user ID, email, and password, and methods like login and update details. The customer, technician, and center admin classes inherit from user implementing. You can see implementing classes inherit from role specific logic, and other classes includes equipment. Like you can see equipment store device details, repair job like links admins and technicians assigns a job and tracks progress. Bill where handles the bill payment summaries. Notifications stores alerts it tied to user IDs like notifications to the user IDs. Supplier inventory in its part they maintain the supplier info and available parts. Each class plays a role in creating a modular, loosely coupled system. Relationships like inheritance and composition were carefully modeled to reflect real-world workflows. In the next slide, we're going to discuss about the how we use the polymorphism in this presentation. Polymorphism helped me keep the system elegant and reusable. Instead of writing separate methods like login as customer, login as admin, or login as a technician, I used one login method in the abstract class and all child classes inherited. Likewise, update details behaves differently depending on whether you are a technician updating job or preferences a customer updating their address, but we call it in the same way in the control. Like this technique reduced me duplication and made testing and debugging significantly easier. So we have used polymorphism to get to reduce the code duplication and the debugging significantly easier. This made me the process easier. The next slide, we're going to discuss about the design patterns. Like design pattern have two, like we can see design patterns have two methods. Like they are factory patterns and observed patterns. Factory patterns. Let's first discuss about the factory patterns. Like the factory patterns are reusable solution to common problems. The factory pattern helps us to centralize the creation of repair jobs. And whenever an admin creates a job, factory class takes over and it assigns a unique job ID and attaches equipment and customer data and checks the technician skill sets and sets the job set status as new. This approach hides complex logic and ensures every repair job is created consistently. And it also decouples the UA and business logic. And any UA element that calls the factory doesn't need to worry about the internal construction rules. And in the second observer pattern, we can discuss the second pattern is useful for the observer pattern and applied for the real-time notification. Here how it works. Like you can see the repair job acts as the subject observed being observed. When its status changes to ready for collection, it notifies the notification service. Like when the device is ready, like when it shows the ready for collection, it sends a notification to the customer like it's ready. And the service then loops to all subscribed observers like email, in-app services, and pushes the alerted alerts to the customers. The advantage is the losing couple. I can add or remove notification channel without touching the, you can see, for example, adding push notification would simply mean writing a new observer class and registering it in with the notification service. This makes the system highly extendable, and especially useful in the production environments where notification preferences can vary across customers. Next slide, we can discuss about the uses of exceptional handling. So in the exceptional handling, user input can be unpredictable. So solid exception handling was must. So I created a custom exception class called authentication clause. When login credential fails validation, this class throws an error. In addition, built-in exceptions like illegal argument exception are used to prevent things like negative values when specifying quantities for spare parts. Handling expression this way keeps the app from crashing, or instead of provides the meaningful feedback to the users. It also guards against the security issues like unauthorized access, like only customers can log in, and it prevents the and unauthorized access and form injection errors. This so we use the exception handling. The next slide we're going to discuss about the design issues. Like any real world system, this wasn't without its challenges. First, handling promotional outs was tricky. Initially, notifications were hard coded. Later, I added a marketing opt-in flag to the customer profile. This will let the system send only relevant messages to opt-in users. Second, error inputs like using letters in numeric fields caused crashes during early testing. Like my solution was built to validations and errors around every user form and encapsulated logic in exception handlers. These challenges made me think like a developer for preparing production, not just passing tests. The next slide, we're going to discuss about the oops. Like this project is truly emphasized the power of oops. Inheritance helped me provide redundancy. Abstraction allowed me to expose only the necessary parts of each class. Like polymorphism gave me flexible behavior while using common interfaces. Before coding, I created UML diagrams to sketch out the each class relationship and responsibilities. This visual thinking reduced guesswork and lead to a cleaner code base. And this is a completely presentation made with the help of the oops. this completely. The project is truly emphasized the power of who. The conclusion, we can conclude that building this prototype, we can the conclusion like building this prototype helped me translate theory into a working system. Like I really experienced how project-oriented design leads to a reusable and clean code. UML diagrams provided clarity and factory and observed patterns, helped me manage complexity and proper exception handling at resilience. Like this helped me to help this like this experienced me how object-oriented designs leads to a reusable and clean code. Thank you so much for watching.